Okay, we're out here reviewing the 2KC system and some of the nomenclature and the functionality. For the initial startups that you may be involved in, you'd kind of like to know how the flow works and what all these components are. So first of all, this is the inlet side of the ammonia system, and normally there is ammonia line hooked up to here, and we have water hooked up today so we can do testing. And this component here is the primary filter and the phase shifter. So the term phase shifter you'll hear from time to time, and there is a core, an aluminum core inside of this housing, and this is the aluminum core that's inside of that housing. The phase shifter housing has this heat exchanger that allows the ammonia to be chilled, and so it takes the bubbles out of the system and allows it to go in as a liquid. There's also a terminal orifice that injects into this, very small, and then it has vent tubes coming out the side, and that's, once again, it's an O21. It's just minuscule amount of flow, about 0.125 gallons per minute, you know, about a really down in that quart range is all that comes out of it to do the chilling. Surrounding that core is a filter, and so the mechanism is very simple, straightforward, and it collects all of the particulate that may be in the system from a dirty tank or whatever before it goes into the pump. So inside this housing is the phase shifter and the core and the filter. All right, from the perspective of flow, the next thing that happens, excuse me, the next thing that happens is the flow comes out and into the pump. And so what we're seeing right in here is the outlet of the phase shifter going into the pump, and this is a view window that allows us to look in and see the flow of ammonia. So that is a very interesting component, and checks the bubbles and what's going on with the flow into the pump. And of course this housing here is another part of the phase shifter, and this is the phase shifter filter and reservoir, and it allows us to inject the flow of the vaporizer unit into here and actually chill for about 3 minutes after we shut down or before we start up. So we get a pre-chill with this system. And it has its own pressure gauge on here, and so this pre-chiller and filter, you can watch the pressure drop over time. It takes about 3 minutes for it to totally drain out with that small O21 orifice that's injecting the vaporizer flow into the system. Okay, out of the pump, this is a sliding vane pump, which means it has 6 vanes, and it's rotational sensitive, and that's why the arrow's on here. And in order to make it rotate only in one direction, we have a check valve located right here that makes that pump only turn in this direction of the arrow. So it's gathering the material, bringing it around, and it actually has a hold of it for about 270 degrees of rotation. Comes out through the top here, so it's going around this way, coming back up around and out and past this high pressure line and into the mass flow meter. This pump is driven hydraulically, and it's driven at this point right here by a flow control valve, and this flow control valve changes the speed of the pump depending on the flow required, and the flow requirement is being computed by the control panel and what we call the electronic control units. And so The idea is that ground speed changes or the rate changes or the variable rate application changes, this valve will change the speed of the motor driving the pump. Motor here, 3.6 cubic inch typically, spins this pump up to about 450 RPM at max, and typical operation of the pump is around 350 RPM, somewhere between 175 and 350 RPM, sliding vane pump. Okay, so the pressure coming out of this pump can be as high as 350 psi, and so these hoses are all pre-tested and actually hammered on to make certain that they can handle about 700 psi. So there's a big design safety factor in the hoses. The mass meter is going to weigh the material as it comes through. This is the mass meter we see here. This is called loop tube technology, and the mass meters are shown up here. And here is a mass meter that was destroyed in the field and got hit by something flying. It flew into it, so we cut it apart, and you can see here the dual tubes and what's inside that meter. And so the flow comes in and the tubes are split, so there's two tubes and they are actually waving at each other, and there's transducers that pick up the signal, and as the flow rate changes, the signal changes because of the torque or the rotation. As it comes back around, it changes the vibration of those tubes, and so as it gets heavier and heavier, there's more flow, you get a frequency change. And the frequencies we're dealing with on this particular unit is at about 1,000 hertz. We get about, 1,000 hertz, we get 350 pounds per minute flowing through here. So very important to understand that this is not a turbine flow meter, it's a mass flow meter. And so as the material gets lighter during the day, as the temperature of the tank warms up, the pressure goes up, you have more volume required, but you still have the same amount of weight. So that's why we use a mass flow meter to determine how much is actually being applied, and we can get it down to like 30 pounds on 10,000 pounds applied. So it's very easy to use this mass meter to change the fields and not have to weigh the ammonia tanks. Very, very accurate. Well, that's what gives a lot of the high performance of the Exactrix unit in the field. And no complaints on delivery, and sometimes the mass meter is more accurate than mechanical scales because they can be out of adjustment. So the ultimate place is to weigh it right at the application point. All right, now the mass meter has a readout, and this readout is under the Great Plains weather shield here, and you can see in through here. Right now we're at rest. We're not putting any weight through the system at all, and that particular unit is able to read gallons per minute, pounds per minute. Now you can scroll the screen and determine the actual flow information. It also has a totalizer, and you can total your field performance and then either use your cell phone to send the report back to the office, or you can use a camera, a little video camera, to send a report back to the cab. But we prefer to use a cell phone. As you change fields, you just photograph it and send it to your office, and you know how you finished up on that particular field. This is also a voltmeter here that double checks the voltage, making sure we're getting the correct voltage to the electronics on the system. This is the power supply for the unit up here for the mass meter, and so this power supply can actually run 2 or 3 mass meters, and so in some cases we have other systems that have mass meters on them, and they're getting ready to send their signals on up to the controller too. So you can run 2 or 3 mass meters off of this one power supply. And The system has been engineered over about a 10-year period, so some of the earlier systems don't have a lot of these special features that we have added, and so we bring in these older systems and get them updated and upgraded into the more current designs. This mechanism here, these end plates are what's called the Great Plains Weather Shield, so we actually have a shield that goes over the top of this to keep the wind and the ultraviolet light away from the high value mass meters and the ECUs. Now on the back side here we have the ECUs, which are either Deere or Trimble or Ag Leader, whatever your preference might be for control. And so you can see there's a lot of wiring here, and that's why we need to protect it. So let's go to the next performance point. As the flow comes out of the mass meter, we're going to use a discharge valve. And so why would we put this discharge valve at this location? Well, it's designed to hold back pressure, and so when you have very low flows, we can get this system to apply at 7 pounds in per acre, typically at nominal ground speed. And this discharge valve allows us to hold enough back pressure up against this so it can't vaporize as it goes through the system. And so when we have real high temperature days where the tank pressure might be 150 psi, we can put on a little more back pressure with this valve to make sure that the tank can't push it through beyond normal pressures, what we're calling for. So allows for better regulation, something that we have learned in the last 3 years, that the discharge valve actually needs to be located right here at the outlet of the mass meter. And of course from here the flow is going to maybe a single manifold. It can go up to 9 manifolds if required. So there's a lot of splitting that needs to be done and controlling that needs to be done with harnessing, etc. But in almost all cases it's all economics. Producers need to have the ability to turn off sections on the machine on these big wide air seeders, or even the 60-foot toolbars at pre-plant band. There may be 4 sections, and so these controllers, these ECUs here, have boom technology, auto boom technology inside, and we can turn those on and off based on the position of the applicator in relation to the technology of GPS.